goal of this video is to go over RC circuits. So let's start off by going over our learning goals and objectives. The first one is to understand that capacitors introduce time dependence to the current in a circuit. The second is to know how to and be able to draw circuits initially and at long or infinite times. And the third is to know what the time constant for an RC circuit is and how it relates to the charge stored in a capacitor. Okay, so let's start off by just first discussing a uncharged capacitor. So the uncharged capacitor will look something like this. We'll have the capacitance C. The charge Q will be equal to 0 because it's uncharged. And then there's also a voltage VC from the capacitor. So if we say that this is the charge at time equal to 0, so now our charge is going to be a function of time. So our charge at time equal to 0 is 0. Then I'm going to let you pause the video for a second and think what the voltage across the capacitor will be at this time. So what's V of C at t equal to 0? Alright, did you at least think of something in your head? There is no harm in saying anything. I'll never know. No one will ever know. This is the beauty of it. So the voltage across the capacitor is the charge on it, Q, over C, and this is going to be at t equal to 0. So now, this, as we said, was 0 over C, so 0. So the charge, or the voltage across a capacitor when it's uncharged is 0. So one way to write this is to say that initially, capacitor is just a wire, or in circuit terms, it's a short. So there's no potential difference across this. So the V sub C is equal to 0. No potential difference, it's a wire or a short. Okay. So, still looking at the uncharged capacitor, let's look at or the case where the capacitor is initially uncharged. So as t goes to infinity, the capacitor is being charged up by some voltage source, so it's connected to some voltage source, and we want to look at the capacitor. So we still have this capacitor, capacitance C. It's going to have some time-dependent charge. It's also going to have some time-dependent voltage. So now, after the capacitor is charged up for some infinite amount of time or some really long time, the charge on it is just going to be fixed. So it's going to be some Q infinity. Now, if there is some Q infinity, think for a second and try to decide what your voltage will be. You have an answer? Great. So t goes to infinity, so this should have been t goes to infinity up here. This is going to be the Q t going to infinity over the capacitance C, and that's going to be